The strategy pattern offers an alternative to subclassing your context. Continuing with our example, we could have created an XML order subclass, a CSV order subclass, and so on. But that would have hardwired the behavior into the context, the order. That makes it harder to understand and maintain the context. The strategy pattern avoids that. In other words, you're replacing inheritance with composition, and that's one of the things the Gang of Four favors in OO design. Important as well is that new strategies can be introduced without having to change the context. That's the open-closed principle from the solid coding principles at work. Strategies also eliminate conditional statements. You don't need that anymore to select required behavior because it's the client that injects it. Strategies can provide a choice of implementations with the same behavior if needed, and the client can choose which one fits best at runtime. And that brings us to a drawback. If it's the client that injects the strategy to use, the client must be aware of how strategies differ, which means that they can be exposed to implementation issues. Therefore, only use this pattern when the variation in behavior is relevant to clients. There's also a bit of overhead in communication between the strategy and the context. For example, when creating export services, some of them might not export the full order, even though we do pass it through. And lastly, this pattern does introduce an additional number of objects. If you only have a few algorithms, it might not be worth the additional complexity. Let's have a look at the related patterns. The Gang of Four only defines one related pattern, the flyweight. That's because strategy objects often make good flyweights. But there's more than just this related pattern. Strategy, bridge, and state are all related and they look similar because they are all based on composition, but they solve different problems. The strategy pattern is also related to the template method pattern. Both are used to vary an algorithm. Template method allows varying part of an algorithm through inheritance, the subclass that implements the abstract base methods. It works at class level, so this is static. Strategy, on the other hand, is based on composition. By providing different strategies, the object's behavior can be altered. It works at object level, so it's dynamic. Behaviors can be switched at runtime. Let's have a look at the module summary. We learned about the strategy pattern in this module. Its intent is to define a family of algorithms, encapsulate each one, and make them interchangeable. Strategy lets the algorithm vary independently from clients that use it. It's a very commonly used pattern these days. The implementation was pretty straightforward. Of importance here is that the variation in which we injected the concrete strategy via a method parameter is a very common approach these days and still a valid strategy pattern implementation. Let's continue with another often used pattern, the command pattern.